Hello. So today I will go through with you guys on definite integral. Okay. So if you haven't gone through or if you are still not proficient enough in integration technique, don't watch this video. Okay, make sure you are really good in it. In math, you should always like see it as a craft or a skill and food. Try to master it in 100% or to the fullest extent before moving on. Okay, else your knowledge will be very disconnected. Okay, so make sure you watch that and be really good. I think about 80% proficient before you come to this video. Okay, so what I want to say about definite integral, right, is that as long as you can form that integration, right, that represent the area and your timing is good, you are good. Okay, solve this chapter is done. Okay, so I have only one concept, right, to pass on to you guys to make sure that you get the area correct. Okay, to make sure you get the area correct. Okay, this is like very frequently overlooked and student, yeah, just don't really bother with it. Okay, that is relating the concept of rectangle and cylinder to finding those areas. Okay, it's not just, oh, this concept only need for that kind of question. No. Okay, so let's talk about rectangle first. Okay, the only thing I want to talk about, right, is that a lot of times student will form the number of rectangles wrongly. Okay, and this has to do with a particular skills like you apply in APGP, summation of series, those kind of stuff. Okay, which deal with the number of terms, understanding the number of terms, getting it right. It's a bit of concept of number line and a bit of concept of iteration. Okay, iteration. Okay, so anyway, the question will write something like this. Then after that, here they will write, don't know, n, then maybe I equals to 1, etc. Okay, so you must, or they may even write something else, or they may even ask you to prove in maybe n plus 1 rectangles. So it's very dependent. Okay, it's very situational, depends on what the question asks. Okay, but most of the time we are talking about n rectangles. Okay, and then I believe in your notes, right, they are talking about 1 and 0. So what I'm trying to say, right, is that regardless of the number of rectangles they want you to split, and regardless of the interval, right, okay, you must get the number of rectangles and the interval correctly. Okay, so let's say they say, oh, they split this, right, say until 1.5. Okay, so they want you to prove that, okay, some summation, right, is equals to the integration from 0 to 1.5. Okay, how are you going to show this, right? Then here there will be a limit. Okay, then usually this n stands for number of rectangle. Okay, so if they want you to split it into n rectangles, right? Okay, so this amount should be 1.5 over n. Okay, so if this amount is 1.5 over n, there need to be n number of them, right? Okay, to make it into 1.5. Okay, so alternatively, you can see it like this. If here is 1.5 over n, here is plus the same interval, right? So it's 3 over n, right? So the last one, right, we can put something over n. Okay, so how do we, as in to express in similar form, okay? So how do we balance this out, right? Is 1.5 n divided by n. Okay, so this is 1.5 times 2, right? Where this is 1.5 times z, and this is 1.5 times y. So based on this, if we are seeing it as counting the right side of the rectangle, right? Okay, there will be, what I'm trying to say is, you see, this one 1 times 1 and this one times 2 So when you just up to times 2, right, you got 2 rectangle. Now, if up to times n, then you got n rectangles. Okay, so yeah, okay, you need to rely on this spotting the there's another so-called another sequence. Okay, and then based on that sequence, you will relate the to the terms. Based on the terms, you will know the number of rectangles. Okay. Yeah, so that's it for this section. Okay. Next up, what I want to say is why is like seeing these as rectangles so important? Okay. Because sometimes, right, maybe you guys will experience this in secondary school, or maybe in your previous tutorial, right? You thought that writing that integration is correct, and then it turns out to represent that area is correct. Okay, so for example, I write like that, and I say I want here. Okay, then you thought that, oh, you got it correct, right? But in the end, it's wrong. Okay, that means, right, your whole question will get 0 marks, and that can be quite severe lah. Okay, I can estimate one question is about 6 to 7, and that is equals to 1 grade lah. Okay, so yeah, that's why the importance of seeing it as rectangle, and rectangle for areas and cylinder for volumes. Okay, so let's say in this example, right, this is the area that we want. Okay, then this is y equals to fx, and then this is y equals to gx. Okay, so a lot of students, some they will wonder, is it integrate y dx or integrate x dy? Okay, it's the same concept as the rectangle thing. Okay, because here is the summation of the height, the height times the base. So the base is consistent, which in this case is delta x. Okay, so if here delta x, then here is dx. If here is y, then here is y. Okay, so if we want to find the area of this thing, right, of this graph, not the area of of this graph, right? Okay, if you see it as rectangles, okay, rectangles under the graph, right? The rectangle is like this. Okay, so once you can see in that perspective, right, you will understand that there's areas that you need to minus off later. Okay, after writing this integration. After writing this integration, right, you need to minus away of something. What I'm trying to say is that integration form is this. You need to minus away this. That's why I keep saying you need to see as rectangles. Okay. Alternatively, right, this question can also be seen like this. I just draw it like that. Okay. Like this, like this. Okay. So there are rectangles here also. Okay. So is these black rectangles, right, minus away these blue rectangles. Okay, you got me? Okay, that's it. What else I want to say? Yeah, that's why you need to see it from the perspective. Okay, so just now we say that, okay, if it's vertically down, right? Okay, it's fx. So this is similar to summing out fx. Okay, summing out the height. okay, fx or gx, whatever, summing up wise. Okay, now after that, I'm seeing it as summing up rectangles. That's why y times delta x. Okay, so if you understand this can be directly converted into like this. Okay, so the area for this, right, will be integrate fx, okay, from, let's say here is a, here is b, here is c, right? From b to c, then after that plus integrate gx. Now I see the other rectangles, okay, from a to b. Okay, so if you want to do it in terms of horizontal rectangles, right? Okay, we are summing up. What are these? These are what are these values? X, right? We are summing out x, and then we are multiplying by the width of the rectangle, which is delta y. Delta y represents a small change in y, a change in y. Okay, so usually after that, sometimes we will write like that, delta y tends to 0. Okay, sometimes we write n tends to infinity. It will result in the same thing. Okay, so this is equivalent to integrate x dy. Okay, so if you want it to do it in terms of dy, then this will be, say here is ABC DE. Okay, so it will be integrating from D to E. Okay, so what is this x? This x, we use the function f first, then minus the function g. Okay, so here x is equivalent to f inverse y, whereas here is equivalent to g inverse y. What I'm trying to say is, okay, this x, the x from this one, okay, is x equals to g inverse y. Okay, then the x from all these, right, from all here, right, when I say x from all here, my mind is like that, the x, all these x, okay, is equals to f inverse y. Okay, so get an idea of why I keep on emphasizing you seeing it from that perspective. If not doing so, you are disregarding, right, that integrand inside, right, represent this whole length. Yeah, that's the disconnection. Like when students see graph, it's just, to them it's just, oh, I want to find this area, but they don't understand what is integration. Okay, that's why, like, always keep asking yourself a bit more. That really, that little extra is what makes you better. Okay, it's not about, oh, this is the way. Okay, then you just do this way better, do this way better, do this way better. No, it's like going from Jurong to Bedok, right? If you keep going the same way, then yeah, you may not find the shortest way lah. Or yeah, okay, you may not be the best navigator to your objective lah. Okay, so now I will talk about volume. Okay, volume is the same thing. Okay, the only difference I want you to know, right, is that always form out the shape according to what the question is asking. That's why you need to read the question very carefully. Okay, yeah, word for word, what is it? Okay, then after that, you say rotate, etc. Then you start to rotate and visualize the 3D image. Okay, don't assume, right? It's just that simple. Follow the question. I cannot say enough about how students just always assume when they see certain shaded area or whatever in the question. No, read the question. The question is the one that is deciding. okay, what you trying to find. Okay, so anyway, let's say um, I will just do one that is rotate about 360, rotate about y-axis with 360 degree lah. Okay, so let's say I got say this shape. Okay, so I rotate. Okay, so I say the from here is DE bar. Okay. Okay, so I want the volume of this graph from y equals to this rotated 360 about y-axis. Okay, so you need to rotate first, because if you don't rotate, you cannot see the cylinder. You cannot see the cylinder, you cannot form the integration expression. You cannot form the integration expression, then yeah, that's it, done. Or you form the wrong one, done, 0 marks. Yeah. Okay, that's why this is so important now. Okay, so anyway here, you rotate 360 degree, right? Okay, really try and visualize yourself, then it's like that, right? Okay, so it's something like this shape. Okay, it's like a hourglass lah. Okay, but it's not exactly an hourglass. Okay, but you get what I'm trying to say. Okay, so over here we are summing up cylinder. Okay, so what's the one cylinder, what's the volume? Okay, is pi x square, right? Because this represent x, so the radius is x. Okay, so it's pi x square. After that, the cylinder height is delta y. Okay, dy. Okay, so just now we say if we write something like that, right, means the integration, right, just write like that. Sorry, if this one delta y. Okay, if this one delta y, then here just write dy. Then the rest just copy. Okay, that's why you don't have, like sometimes you will this one is a y square or dx, got pi or not, got square or not, etc. Okay, always go back to the fundamental. Okay, yeah, it's tedious, but it's fundamentally correct. Yeah, it's not that difficult if you are used to it. I rather be used to it, right? Then I forgot to memorize something wrongly, right? Then I got all the 7 marks wrong. Okay, do something that is fundamentally correct for sure. Okay, then yeah, then instead of leaving your fate to this little memorization mistake. Okay, so anyway, yeah, this will be the expression you need for the volume. Okay, why we don't bother too much with whether this one is on the right of the y-axis or on the left of the x-axis, right? It is because, trying to understand, you are summing out cylinder. That's why, yeah, it's just pi x square, pi x square, pi x square, so that initially, even when there is a negative x, right, then it will become a square. So all these summation, right, are all positive. So it doesn't matter. Okay. So yeah, that's why volume you don't really have to care about. Oh, now is it negative or positive? If even scenario like this, yeah, I say like that. Go and find area. Okay. Don't go and find volume. Rotate 360 degree about y-axis. Okay, it's just still pi x squared. Okay. So that's it for this lesson, and I see you in the next one. Okay. Bye bye.